Hey guys, welcome back to another mind-blowingly amazing video on the Mind Blown channel. Today I'm going to be telling you why I haven't been uploading for a while, and I have been sort of taking a little bit of a break from Cliff. So let's get right into it. This is a picture of what I've been working on, and it is
a temperature sensor, and it's for a competition called Science Olympiad, which is a national competition where students compete against each other. Students in middle school and high school compete against each other to make a device that performs a certain task and then are scored based on that, or you take tests and stuff just about science. With this one, we have to build a temperature sensing device that will tell you the temperature and lights up one of 3 LEDs, red, green, or blue, depending on that temperature. This thing is a thermistor, a 10K ohm NTC thermistor, which is what varies based on temperature, and the Raspberry Pi reads that temperature based on how long it takes for a capacitor to pulse, and that lights up the LEDs based on that.
At the last competition, the detector performed surprisingly well, usually predicting within a degree of the actual temperature of the water. But for state competition, I'm going to make the device smaller. And that's pretty much it, I guess. So let's get right into it. So here I have the microcontroller that I will be using. It is a pretty great board. It's the Adafruit QT Pi, and it connects to a computer using USB-C, which I think is nice, and it's got the little stemma output here, which I'll be using to connect to this little OLED display, which has a stemma also. This is very small compared to the Raspberry Pi. As you can see, it's like as big as the Ethernet port, but yeah, it will work for the purpose of this since this is not a complicated machine. Link in the description for both of these. But before we can build, it's time to disassemble.
I'm gonna miss you, Detector.
So let's get right into it.
So as you can see, this thing is like just about as big as the whole Raspberry Pi itself. You can see it's shrunk down a lot, and I guess I just need like a box to put it in and program it now. So yeah, so I went ahead and made everything a little bit shorter, so I cut some things down and made sure these are shorter so they can fit in the box I selected, which was the Adafruit box that this came in. So yeah, it fits pretty well, but I guess I just need to cut some holes and stuff for everything to come out of. Okay, well I guess now it's time to program this thing, and then we'll see if we can measure some temperatures.
You may not be able to tell, but it's been a couple of weeks because of this little display here was way harder to control than it had to be. Link to my GitHub page in the description, where there will be step-by-step instructions to control the display using a QT Pi for you to follow. As you can see from this video here, it works now, but it only displays voltage, which I don't think you can see because of the poor camera quality. All I have to do now is measure actual temperatures of water and their corresponding voltages, put them in a scatter plot, then find an equation that will give me voltage to temperature conversion, which I then can also display on the display. So let's get measuring.
Booklet for this week?
Okay, this is the graph on the calculator. Now to make an equation. After this, I went to test, and strangely, it was outputting the wrong voltage. That is because there was a leak, and so water was getting into the probe and short-circuiting, and so circumventing the thermistor. So I got some shrink wrap, and now I see a little much better, but I have to retake all of the information and make a new equation for voltage to temperature. Even though my display broke, I was able to find out the voltage from my computer by using a print function and connecting the power to the computer. And now after everything, it's actually kinda accurate. I guess it's just time for the LEDs. So I made the LEDs come on based on the temperature: red if it is above 50 degrees Celsius, green if it's between 50 and 25, and blue if it's below 25 degrees. Those are just arbitrary numbers. You, if you want to make this, could do any numbers you wanted. I hope you enjoyed the video. Make sure to smash that like button and subscribe if you want to see more videos like this one. And I'm thinking of, in the future, possibly like 3D printing a case and moving that from breadboard into just a much more compact design. And maybe even putting like a logo on it or something. I don't know what logo I would put on it, but it would be kind of cool. So if you want to see that one, make sure to subscribe. But that video probably won't be here for a long time. So yeah.